very much for your patience. My apologies for being too quick in the opening. I should have said more. That said, as I was saying before I was told that I was a little quick, we do have a lot of really, really excellent content this year. We are kicking off with that excellent content, starting big and continuing that way. Our keynote speaker this morning to open our conference is Dr. Gordon Ings from the City of Cape Town's Data Science Unit. Gordon lives in Bloemfontein with his wife Rebecca and daughter Emma. Beyond any and all digital plumbing, which sounds like many of us, he enjoys cooking and long walks. Yes to the cooking, not so much the long walks. Gordon holds an undergraduate and master's degree in electrical and computer engineering from UCT, with a focus on distributed digital systems and remote sensing. And then that wasn't enough, he went on to get a PhD from Imperial College London, where he researched heterogeneous computing under Dr. David Thomas and Professor Wayne Look. Upon completing his PhD in 2015, he returned to work for Amazon Web Services in Cape Town, working on the Elastic Compute Cloud service. In late 2018, he joined the City of Cape Town as its second data scientist, and since 2021, he remains with the city but has had his job title changed to reflect what he actually does for a living, and is now titled as a data engineer. Gordon, take it away.
Okay. Good morning, PyCon. I would like to start somewhere quite dark and probably quite a bit scary. Back in late April 2020, it was, the initial 3-week lockdown had just been extended. We were facing a large degree of uncertainty. The word unprecedented had become truly precedented. And, we were sort of adjusting to this new world that we found ourselves in, being at home all the time, figuring out the keyboard shortcuts for Zoom and Microsoft Teams, or the city's iteration, which was Skype for Business. And we really, but there was growing anxiety. Case numbers were starting to climb. The healthcare system in Gauteng was starting to creak. And yeah, it was a time of increasing anxiety, particularly for myself and my colleagues. But other than the existential dread which everyone else was feeling at the time, we had a question, had what we had been building frantically for the last few weeks, was it good enough? Was it ready for what was about to come? So to take a few steps back, as was said in the introduction, my name is Gordon Ings. I'm from the City of Cape Town. And in this talk, I would like to tell you a few things that we've learned from doing data science in local government here in South Africa, and in particular at the City of Cape Town. So, the way I've structured this talk is that I'm going to talk about 3 things that we've learned, three lessons that we've learned over the course of the last 3 years. And those 3 lessons, they're a little bit mysterious right now, but they'll become clear as I go into them, I promise. The first one is really about trusting people with information. The second lesson is about trusting people with choices when they have the appropriate information. And the third thing is getting people into a place where they can actually trust. And, don't worry, there's also some good technical content in here too. I'm not just going to be talking about abstract, human stuff. We found this concept of tidy data really invaluable, and I'm going to be talking a little bit more about how that is related to our work, and in particular in relation to the creation of what we call coherent data sets. The next thing is like I think almost every data organization that's done any sort of significant work, we run into the curse of dimensionality, and I'm going to go into a little bit of the digital sage wafting and how it is that we've dealt with it. And then finally, when under pressure, how to build super scalable, super reliable data products. It's not a perfect method, but it's something that we found helped us get things out and up really quickly, and thought it would be great to share it with you. Okay, so I think actually a lot of this has been covered in my introduction, so ably done. So I'm not going to spend too much time talking about it. I had a bit of a strange career trajectory in that I went from academia, from the sort of heterogeneous computing, high performance computing world, to AWS, which is also high performance computing, but in a slightly different setting. And if you were trying to launch instances between the period 2016 to 2018 in Sydney, I'm really sorry about that. We did find the bug eventually. Yeah, it was, again, I must reiterate how sorry I am. But then, something that really I found while working at AWS was because of the scale of the systems, the only way that you could reason about them was probabilistically and was using statistical methods. And so when this opportunity came up for the city of Cape Town advertising as a data scientist, I thought, ooh, that sounds really interesting. I can apply all of the statistical stuff I've been learning, and I can really satisfy a genuine question I have, which is, what does a modern tech job look like in South African local government? So I joined the city as data scientist number 2, and as of last year, over the last 4 years, I've probably spent 70% of my time doing data engineering. So I thought I might as well just make it official and change that. Strictly speaking, my job designation is as a principal professional officer, which in the city world means that you're a technical specialist essentially. So if you're a lawyer or a doctor, you are often employed as a PPO, as they're called. I put my Twitter and GitHub up there. Please feel free to get a hold of me and shout at me online. Yeah. So I came to the city and I had a lot of ideas, and I think I was suffering from something called Shirley syndrome, which is that surely if you did X or Y, then something great would happen, right? And of course, there's a bit of hubris there that you've got to trust that intelligent people have probably applied their minds to this problem, and there's a good reason that they're not doing it. So one of those ideas that I had was, I said, surely, the city has so much information about people. Why can't we unify that all? And so that when someone phones into the city call center, the call center agent, because of the call ID, answers the phone and says, "Hello, Gordon, how's it going? I see that, we just sent our bill to you. Did you get it?" And sort of really bring everything we know to bear about someone. And actually, that's not such a great idea for at least 2 reasons. One being that anyone who's worked and done any sort of work relating to things like CRM systems, billing systems, the integration work to bring together that data set would be non-trivial. It would be a lot of work, right? And another thing is also, what would the user experience be for the agent? How would you be able to create this experience that someone would have, right? That would allow them to have the relevant information they needed from amongst all of the information that we know. So, that was amongst the ideas I had coming to the city. Another one was, why don't we just text mine all of the public submissions that we receive? So whenever the city is putting a policy out for public comment, we capture everything digitally, we run some NLP against it, we learn about themes and keywords. And I actually think that's an interesting example because I don't think it's necessarily a bad idea. But the problem there was that the audience was, thank you, it wasn't clear who the audience would be. Would it be the politicians? Would it be the people writing the policy? How would it fit back into it? And that's a sort of reoccurring theme that I'm going to come back to again and again, which is about the gap between an insight or something that you've extracted from some data, something that you've learned, and actually putting it into action and actually conveying it to someone who can use that information. That gap needs to be as thin as possible, and preferably non-existent. And I'm hopefully going to illustrate this where a project where I think we got this right, where I think we got the information to the people that needed it. And because we trusted them with that information, they were able to do some pretty cool things. So, just to start off with, make sure I'm in the right place on speaker notes. Very soon after joining the city, we were asked to work on an internal initiative relating to these things called service requests. Now, you might be wondering what a service request is. A service request is, at its simplest, when I'm talking to tech audiences, I always talk about them as issues or issue tickets, you know? All it is simply someone saying to us that there's this problem with what the city is providing to you. So, for example, a blocked sewer or a pothole or a verge that needs to be trimmed. And it has sort of three core components. There's actually a lot more attributes that we record relating to them, but when the issue was created is a very important one, obviously. The classification of that issue, and it can actually often be a collaborative endeavor between the person reporting the issue as well as the agent capturing the issue. You know, they'll ask them some questions and work out exactly what the thing should be classified as. Yeah, like there's an important difference between stormwater drains and sewers is not, you know, I'm still not entirely sure I understand the difference. And then finally, we need to know where the issue is, you know, locating it in space. And this is all important for us to be able to work out, you know, how to address the issue. Now, something that's quite important about these guys is that there's a lot of them. The city logs somewhere around 1 million service requests a year. It's around 3,500 a day, and 24 hours a day. We have various online portals, but we actually also have agents who are awake throughout the night to log these issues. So there's a lot of them that are coming in. Another thing is that they're quite diverse, and I apologize about the font, it's a little bit small. But this tree map here, these are the different proportions, are the different, some of the top request types. And you can see that it's quite largely displayed. There's the big block in the corner over here, that's blocked sewers. The one in the top left, that's no power. Then we have no water if you have a water management device, street lights, stolen bins, damaged bins. And you know, you'll notice something about the proportional volume is that the things that viscerally go wrong, when you have a blocked sewer, you really know about it. Those are the things that tend to get logged, and sometimes get logged multiple times. So, you know, this is an important data set. But just to summarize, that there's a lot of these things. They're pretty diverse, and they matter a lot to the city. This is probably one of the main interfaces between our residents and the city, the organization, both the administration of the city as well as the political running of the city. And you know what they, you know, one of the things that really matters a lot about them is their duration. So how long it takes us to attend to these requests. And as part of this internal initiative, which we were asked to join, there was a big focus on saying, how can we improve the duration of our, you know, the time it takes us to attend to these issues? So the first thing we did, being good data scientists, is we started plotting some histograms. And what I've got over here is the overall one for the year mid-2017 to mid-2018, which is the city's financial year. And you can see we actually got quite a nice log normal distribution. Each of the bars represents 5 days. And I've also put the highlighted the upper decile. So the first red line is the 50th percentile, the median, then the 60th, the 70th, the 80th, and the 90th. And you'll look at this and you'll see, okay, there's, you know, we've got quite a nice story. And when we looked at one of the individual request types, so this is the blocked sewer one, doesn't actually look that different, right? You can see that these two things, these two distributions look quite similar. The numbers are quite similar. The red lines move around a little bit, right? But not much. So, you know, that's all good. But then we looked at another, and this is also one of the top request types, which is plumbing. So the city operates quite a large amount of rental stock, and these are requests for us to fix the plumbing in that rental stock. This is quite an important thing because if the plumbing is broken, very often there can be water damage, and the rental stock itself can be affected. So it's a very important request type. But you'll notice suddenly, whoa, okay, still a log normal distribution, but quite a few modes going on. But also, if you look at the numbers at the bottom there, our median value here is somewhere, it's around 25 days for us to attend, well, was 25 days in 2017, 2018 to attend to a plumbing request. Whereas the median time to attend to a blocked sewer was just over 10 days. So you can see the different request types had very, very different latency distributions. And that's, if you think about it, makes complete sense, right? The act of going and unblocking a sewer versus fixing a plumbing operation, okay, maybe those activities are vaguely comparable, but trimming a verge, collecting branches from a tree that's fallen over, filling a pothole, those are all very, very different activities. So it makes complete sense that the latencies and times involved in that would be completely different, right? And so we looked around, and what we worked out was that, one of the most powerful instruments in the city is performance indicators. And we looked at the performance indicator for service requests, and we saw something interesting in that there was a single target set for all service requests across the whole city. And I've chosen a particular group of departments. They fall into the same directorate. And I'm just reflecting what the indicator score was for them. And what we saw was that some departments were doing a lot worse than we expected relative to what we knew about the operations and what was going on. The score for recreation and parks, which is one of our bigger departments, was at like 50%. But, we spoke to the people in the department, we looked at the work they were doing, and that didn't seem to align. And so what we realized was that because everyone was being judged according to this distribution, when actually, for example, a lot of distributions looked quite different, we were ending up with an indicator value, a signal that wasn't terribly useful. It wasn't very helpful to someone to know their performance, because recreation and parks were inclined to dismiss the indicator and say, look, a lot of our work takes a lot longer than 25 days. A lot of it's seasonal, actually, because it relates to the physical seasons. We're not going to pay too much attention to this, right? So what we said is we should change this, and we should have a target per notification type, or per request type, right? And by doing that, we could have a reasonable amount of time associated with each type of work, except the heterogeneity of the different types of tasks that people were doing. And as a result, we could then have an indicator that would be a lot more meaningful. It would still be comparable, because what we could do is measure what proportion of notifications were being closed within their targets, but we would still allow for the diversity that existed within the different activities that people were doing. But something we were also very clear of, and it's a very important principle to us, is that the same target gets applied across the city, regardless of where you are, because that's a very important principle in terms of how we service our residents. And you can see now that when we applied this new target, this new regime, recreation and parks, they looked a lot better. And that number was much closer to our perception of, how they were operating, and certainly some of the other things that told us about that. But that little detail of saying, oh, we should just have a target per notification type. This is the actual tree map of all of the notification types. There's 850 of them. To set a target for every single request type in the city was not a straightforward endeavor. Sure, we could do some, prioritization based upon the size of them, but there's still many, many, many request types that we needed, and we needed information about what was a reasonable time to actually close those things. So, there was three things we could have done here. The first thing we could have done is done some fancy modeling, and as data scientists, we were very attracted to that idea, maybe some sort of agent-based simulation, And try and work out, the actual intrinsic time it takes to do these different things, and then come up with a reasonable number for these different activities. Maybe do something about like how long it takes to travel over the city, etc. Right? Another thing we could do was just ask people at random. So we could just go to people and say like, hey, what do you think is a reasonable number here? And maybe send out some spreadsheet templates, get them to fill them in, and then we'll be done, right? Or we could do nuanced data-informed consultations where we work quite carefully with our colleagues to try and work out, provide them with something relevant, and then try and find a number that makes sense to them. So based upon the flippant way I described the first two and the more serious way I talked about the third one, you could probably guess which one we ended up going with. But it's worth just pausing for a second and thinking about why number 1 and 2 don't work. Number 1 is a bad idea because, sure, we were smart people, we could probably apply our minds to these things, but at the end of the day, we wouldn't have buy-in from the people actually doing the work. We would be holding them to a standard that had been derived from, I don't know, some modeling process that they weren't fundamentally involved in. And so the likelihood of them owning that process or owning that target was low. The second one probably wouldn't have that problem because we were asking them to give us the number. But there's all sorts of reasons why people are inclined to not give you a reasonable number. Generally speaking, our experience has been that people struggle to reason probabilistically. So if you say to them, what do you think the 80th percentile is of your work? How long does it take you to attend to 80% of your requests? The answer they're going to give you is going to be way distorted because they are more often than not thinking about the worst cases they've had to deal with recently, the ones that have taken up all of their time. And more often than not, those cases are all sitting in that remaining 20% of the tail. In fact, we looked at the distributions and made that determination, right? So what we did was we put together some information for the different, and this is actually some of the request types within the Recreation and Parks Department. And we looked at the different durations, and we looked at different particular deciles. So we looked at the median, we looked at the P80 and the P90, because that was likely where the service standard was going to be set. We were going to ask that they do 80 or 90% of their work in certain timeframes. And we presented this information to them. We said, look, this is historically how long these things have taken. Would you like to apply your minds and please set a target based upon that? And, we actually went a little bit further once they had given us some initial numbers in that we built this tool that allowed them to see what the relevant service standard would be for the different types of notifications. And this is just in terms of the city's organizational hierarchy. And then we did another version, which was based upon maps. So you'll see that the different colored dots indicate areas where they're sitting outside of that service standard. So they could apply their minds and think, okay, we know that we have problems in that area. It makes sense to us that the service standards is not correct there. And actually, as just a fun aside, although this project finished in early 2019, we only retired these tools a couple of months ago. And within a few days, I received several emails of people complaining who had been carried on using these things. So, we definitely found something there that I think resonated with people. But I think, what was very interesting about this process was that we also did something a bit unreasonable, which is that we went and spoke to every single department. There was approximately something like 40 to 50 departments that were relevant here. So we did something like, 20 departments, but it was multiple meetings, was multiple hour meetings. So we probably spent something like, I think at the end of the day, all told, it was something like 30 person days, full person days, in discussions, not doing the data prep work, not actually, wrangling the data to the right form. And, to get people to look at that information that we had initially provided, reflect on it, and make sure that it was something that was reasonable. And what was quite encouraging was twofold. First thing was that it was really, people were really enthusiastic and receptive to this. They really liked the fact that we had engaged them. They really appreciated that they were being consulted on their domain of expertise. Shocking. But then secondly, it also gave some of my colleagues to really present themselves as the true servants of the people of Cape Town that they are, in that quite often they set targets that were unreasonable. They set targets that they weren't at yet. They didn't just set the target that would be easy to achieve. They set the target that they thought was right and correct. And so I want to particularly highlight my colleagues in solid waste management as well as traffic management, the people who look after respectively the people who look after the rubbish and the people who look after the traffic lights. They set targets that they weren't achieving at the time, and this is one of the requests for solid waste management. The red dotted line is their target, and you can see how very quickly it's only been right in the last 6 months to year that they've been able to get themselves consecutively under that target line. They set a target, they stretch themselves, and I think they deserve to be very recognized for that. And I think this is the first thing that we learned, is that we really need to trust people with the information, but it's got to be not data, it's got to be information, it's got to be something that means something to them. When we do that, good things can happen. Now, we have an associated technical lesson, which was that we found the concept of tidy data really useful. And I know that this is coming from the R world, its own column. Each observation is in its own row. So that basically means that each row of your data set, if you're thinking of a giant spreadsheet, is something that you care about. Each variable is something that you care about. Each variable is something about that thing in the row that you care about, and that you try and group observations together that are related and relevant. So for example, we would build a data set of all service requests. We wouldn't create separate data sets of service requests, I don't know, split out by department, because they're the same thing, although there might be an attribute which tells us something about to which department it belongs. And just to give you an example of what messy data looks like as opposed to tidy data, I'm sure all of us have seen a spreadsheet or something that looks like this. So what we have over here is we have all the organizational units, and then we have counts by year. And this is actual service request counts for different departments within the city. And there's actually two problems with this. The first problem is that we've actually got multiple attributes inside here. We've got the directorate and the department, and these are just internal city designations, but these are two different things that we care about inside the city, and conceivably we might want to at times reason about things on the directorate level, and other times we might want to reason about things on the department level. The other problem is that we have an attribute that is being stored across columns. So we've got the number of notifications created in a particular year, but the different years have been spread across different columns. And the problem with that, I'll illustrate in a second with a code sample about how to get to that. But what a slightly tidier version would look like is something like this, where we have our organizational units still, but we now have a column called year, which is about the year that we care about, and then there's the value associated with that year. And to finally complete it and to make this data properly tidy, we actually split out those different directorates and the departments, and then we have those years, and then we have the value associated with it. And the reason that you might want to do something like this is that conceivably, if you wanted to ask the question, what's the cumulative number of notifications or requests we've had over time, you might write something like this at the top here, right? And for those of you who aren't familiar with pandas, syntax, don't worry about it too much, but basically, I'm just selecting across all of those columns and I'm doing a sum, right? Whereas when we have the tidy one, we can do something a lot cleaner and a lot more elegant, right? In that we can group by two of the attributes, which, if you'll remember in my data set, is the two columns that are not there. And then I'm just summing across that volume column. So I'm saying, per department, give me the value that's there. If I say, for example, wanted to know my totals per directorate, I would just exclude that department parameter that I'm passing in there, right? Whereas for this guy, to try and get the totals per directorate, would be a bit more complicated. I'll probably have to do some sort of sum across the different organizational units, and I'd have to have some sort of logic for working out whether I can combine the organizational units together or not. So you can see that by cleanly separating out the attributes that we care about, as well as structuring our data, it allows us to do a lot more, to work with the data in a lot more flexible way. And, just in case you're worried, like, okay, well, that's great, to have this idea of tidy data, but isn't that going to involve a whole lot of cleaning work to get that data into that form? That's right, but do remember that we have some very powerful tools at our disposal, thanks to the Python community at large. So what I've done over here is I've used the melt operation, which is all that does is it takes the columns and it melts them into a single. It turns some of the column names into a variable and then some of the associated values. And then I've also over here I've just done the splitting out of the organizational units, and there's probably a cleaner way to do it, but I was tired last night. So, what you can see over here is that, we're able to very quickly get to data that can be in this form, coming from a messy form, right? But what's quite interesting about this too is that very often if you talk to people about messy data or unclean data, they're often thinking about something else. They're usually thinking about, what about if there's like missing values or strange values in certain columns in my spreadsheet, etc. And I just wanted to remind you too, this is also something that we found is like quite a superpower that people who have access to our take weeks, and very quickly, and like just using some chained expressions, you can very quickly clean up a data set and get it into a form that's ready for analysis. So we're much more preoccupied with the tidy data because we think it enables good analytics. And we think it's part of a three-part story about what enables good analytics. Is it's got to be tidy, needs to be relevant, and it needs to be accessible. But there are some, and we call these things coherent data sets, but we do need to be careful that there's still, getting to these coherent data sets, someone needs to make a decision about what data gets extracted, what data set you're going to do. Someone's going to decide what the observations are. And, for example, in a place like the city, making a decision about, okay, we're going to extract the formal billing data set. What about all the people who live in informal areas? You're not going to get any visibility of them by looking at the formal billing data set. So these decisions don't have implications, right? What are the observations of the data set? What do the rows mean? And what do the columns mean? So that's the first technical lesson that we've learned, in that practically providing people with data, this data set, that citizen notification data set that we extracted and we're using to do this work, has become one of our hardest working data sets. And we've done it, and it's been used repeatedly. And it's not just being used by us, it's being used by our colleagues across the city. So, it's one thing to trust people with information, but you have to get things to a place where they can have that information in the first place. And we think these coherent data sets are an important part of that story. Okay, lesson number 2. So chronologically, I should probably jump to the pandemic stuff, but for narrative tension reasons, I'm going to jump ahead instead. So that, the selection committee is definitely getting what they paid for, and to be clear, I'm not being paid. So we were roped in late 2020 into an initiative to look at service delivery quite seriously in the wake of the pandemic. And it's actually nicely illustrated by that service request information, in that you can see during those initial hard lockdown periods, it wasn't that things weren't going wrong with the city's infrastructure, it's that people weren't reporting those things. And we weren't accepting certain types of requests because we said, no, we need to focus on our core work. We're not going to be looking at things, right? So we needed to then address the fact that there was now this big, there was a backlog that had built up, there was a gap, that, we didn't know exactly what the state of things were, so we needed to get things back on track. Hence, there's this program called the Service Delivery Turnaround Program. And essentially, the Service Delivery Turnaround Program, as amazingly illustrated by my diagram, it had like this feedback loop form where a group of people, us, would look at the data, would look for interesting things. We would ask some questions to our colleagues in the various line departments, and then they would investigate and work out what was going on, or they would provide commentary about why we were seeing these problems. And then they would come back and we would have a discussion, and where relevant, we would motivate for and escalate issues to be taken on by the senior leadership of the city, right? This loop sounds all very good and well, but we had to decide what was the thing we were actually going to look at. What were the metrics we were going to care about? And we had two candidates, really. The first one was what we've just been talking about in the previous one, this nice service standard metric, which we had spent time constructing. The other one was what was called the backlog, but it's really the throughput. So the number of requests that had been opened in a given time period versus the number that had closed, right? And they both had their merits, and we couldn't decide between which of these two metrics we were going to use. So we thought, well, hang on, doesn't it make sense? Because actually, the strengths of the one metric very definitely offset the weaknesses of the other, and vice versa. We said, well, why don't we actually just look at both? And this sort of quadrant plot gives you some idea of that, in that when we have a low backlog at a high service standard, that's where we want to be. But if we had a low service standard and a high backlog, that meant that things were probably in quite a bit of trouble, and that we seriously needed to pay attention there. Then there were these other quadrants, and these other ones told us something quite interesting. That if we had a high backlog but a high service standard, that probably meant that our backlog was building up, but we were managing to do something in the right time frame. So that, we had some triaging on the go, right? Whereas in the top left hand, we might have a low backlog but a low service standard. That suggests that we've been working through some old issues. We've been clearing out our backlog, and as a result, we have a low thing. But what this helps you do is make sense of what's going on, right? And just to convince you that this isn't just like crazy plots that I was drawing on my tablet, this is an actual plot that we put together, where these are the different request types, and then these are those different quadrants that I was just speaking about. And what we did is we could use this to inform our our questions that we then went off and asked people in the department. And then the final point to note here is the size of the plots relates to the volume. So that obviously that helps guide you towards the bigger request types. And I must really give credit to my colleague Colin, who built this plot originally, and he's here today. So please, feel free to chat more to him about the dark magic he did to get this to work. But what was great here is that it started giving people the opportunity to navigate these trade-offs, and actually, this plot gives you some nice idea of, you can almost see the syncopation of people navigating the trade-offs, right? Where the red line over here is that service standard, the blue one is that backlog, and I inverted the backlog axis just to accentuate this. But you can see this is when our backlog is high, but our service standard is good. We then climb into the backlog, and our service standard tanks because we're closing a lot of really old stuff. But you can see that here is 0. The perturbations are getting, as the program went on, are getting tighter and tighter and tighter as people are navigating that trade-off, and they're making choices about how to balance these two competing concerns, right? And this is another plot that we did. This is a time series. Actually, the best one to look at over here. So this is some of those metrics over space. Actually, it's better if I do it this way around. So this is the change in those metrics over space using these uniform grid cells. And what you can actually see now is I've turned on 2 layers. One is about the change in the backlog, and then the other one is about the change in the service standard. And you can see the very dark red ones. That's the places we have to worry about, where our backlog has gotten worse and our service standard has gotten where's one of these nice red ones? Yeah. That's where both of those things have gotten worse. So we need to really dig in and pay attention to those areas. Vice versa, correspondingly, the blue ones are the places where both metrics have gotten better. And so, it's really somewhere that, I think it's one of these ones. That's somewhere where we really want to, things are going well there. Maybe we can look at what we're doing there and transfer it to other areas, right? And then you get these like purpley ones, which is some mixture of the other ones. And we can reason about, okay, maybe different things are being applied in different areas. And you know, just to be clear, you know, a lot of you are probably thinking about Pareto trade-offs right now. And that's exactly what I think we're doing here, right? In that if you have some metric that you care about, for example, pancakes baked, and then the other one you have something cupcakes baked. If you have a finite amount of resources, if you want more cupcakes, you're going to have to give up some giant pancakes. I had to make them giant pancakes because of the numbers. But to navigate this trade-off, in the context, provided that you have a reasonably efficient process of translating one for the other, you're going to be moving yourself along a curve that looks something like this, right? Depending on the relationship between the two things that you care about. And it is possible to move the curve, but either you need more resources or you need to optimize your processes in some way. And that was something that we were quite interested in this program with relation to the metrics that we cared about, right? Oh, can't see those now. But this is an extract from one of the dashboards we had relating to this program, where we optimized. By the end of the program, we were able to improve both of the metrics that we cared about. So that was a sign to us that we had not only helped people navigate those trade-offs, but we had helped move that curve that they were moving along within their departments. To be honest, the service standard metric didn't improve that much. It was the improvement was somewhat marginal, but that was fine because actually our big focus was that backlog metric. Okay, so you know the lesson here that we learned was that by providing people with relevant data and relevant information, remember that service standard metric was something that they had been part of creating. That backlog metric was one that they were familiar. It's another official indicator that people get measured against. They were very familiar with it. By presenting it to them as a choice that they were having to make, that they were having to balance between these two things, I think we got away from this idea of people gaming metrics or gaming performance indicators. And we put them and we created a world in which simply the easiest way to do the right thing, well, the easiest thing to do was the right thing, was trying to improve both of your metrics. But most of the time you were managing the finite resources that you had to try and balance between those two things. Okay, but associated with this, we very quickly ran into this problem, which I'm sure anyone who's done a bit of data work has run into too, right? Which is that if you think about the number of organizational units times by the number of time periods that you care about, times by the number of spatial units, this will give you the number of metric values that you are going to be computing conceivably, you know, as part of your work, right? And if I plug in the numbers for, this is going a little bit more fine-grained in the context of the city. There's 670 organizational units where we were wanting to compute these metrics. There was 2,500, there's 670 service request types that we were computing the metrics across. There were 2,500 days across which we were computing. We're doing the metrics on a daily basis. And there were 620 of those uniform hexagonal grid cells that we were computing. Those numbers multiplied together give you 1 billion. The service request data set, you know, right now is several million values, several million observations, fits more or less into the memory of a working memory of a laptop. 1 billion values generally does not. So, you know, this is the problem which happens, which is that the moment you have multiple groups of dimensions that you care about, and in a lot of contexts, it's going to be the case that you care about stuff over space, so it will be probably at least two dimensions. You probably care about things over time, and it depends on your time granularity as to how big that dimension will be. And then you probably care about it across some other organizing principles, as we do, our organizational units. You're going to end up with these very large values. And we've basically come up with 3 different strategies for coping with them. The first one is avoiding doing the computation for as long as possible and doing it on an as-needed basis. The second one is to try and, where you can't do that, keep things as simple as possible. And the final thing is about learning to learning to shard across them. I think I'm going to skip over the third one because that's a strategy I'm pretty sure most people are familiar with. So this is actually an extract from a tool where it's plotting that service standard metric. And what the video I'm doing in the video is I'm selecting a particular department, and then the tool is dynamically recomputing the metric based upon what department you asked to be done. So the user is guiding the tool to tell it which metric value should I compute. So rather than computing across all organizational units, it's only computing across one organizational unit because it's responding to what the user needs. You need some sort of BI tool where you can express the computation in that, and if your metrics depends on the complexity of your metrics, that can be easier or harder. But yeah, that's one strategy we found that worked nicely. Another one is to exploit linearity. So to compute those different metrics, the service standard metric as well as the backlog metric, we actually only needed 3 values. The number of requests opened on a particular day, the number of requests closed on a particular day, and then the number of requests closed within target. And what you could do is you can compute these 3 values, which are just simple counts and sums, across those dimensions that you care about. And then when you need to compute your metrics, you can just use these values because they're linear combinations of the things that you care about at the end. And if you think about something like the service standard, which is a proportional value, if you computed that value on a per unit basis, to recombine that and to say roll it up to like say going from that spatially disaggregated view to the citywide view would take would be like some quite complicated weighted sum that you would have to do because it's a nonlinear value, right? And then the final technique is to use sharding, which is basically exploit the fact that you have these different dimensions and break up your data set so that you can process them separately and compute the values independently across multiple machines. And our job scheduler, we use Airflow. So we just have a bunch of Airflow jobs that are computing. We compute a shard value for each observation, and then we use it in each one. Right. Okay. Final closing stretch. Back to that cold, dark morning in April. So this is the final lesson that we've learned. Well, the final lesson I'm going to talk to you about today was that with the onset of the pandemic around mid-March, we were pulled out of our normal work and asked to start building data products that basically did 2 things. Told us about how the pandemic was rolling out across Cape Town, and then the second thing, telling us about what was the status of the city's day-to-day operations, our ability to deliver services to residents. So, no big deal like this. And to be clear, at this point, our department, we were 2 technical people with a manager who, actually did quite a bit of coding during this time because we were that pushed. And we built a tool that, we built a series of dashboards, and this video is just giving you an overview of one of those dashboards that showed all sorts of information in support of those 2 requirements, right? A lot of the information relates to health, the pandemic information, so the case instances over space and over time, also the flow from cases to hospitalizations to ICU beds, and then unfortunately to fatalities. It's, this was all information that we had to convey. And, ostensibly it was for the purposes of like risk management. People could then make judgment calls about, okay, should we try and do this work, or shouldn't we try and do this work given the state of the cases? Is it safe for us to send people out to particular areas given the number of cases, etc.? But, what was quite interesting was actually when we looked at the dust settled a bit and we looked at what people actually were looking at, we found the usage numbers pretty low. Not a lot of people were looking at our dashboards, and we sort of made peace with that. But then we looked a bit more carefully and we spoke to the people who were using the dashboards. And it turns out a lot of what they were doing was using our dashboards and repackaging that information to put into slides. And then those were being presented at very large fora. So hundreds of people were actually consuming the content that was being provided on our dashboards. But most of them were getting it via these slides. They weren't getting it from interacting with our dashboards directly. And it wasn't like we had restricted access or not allowed people to get to it. but what the slides had that was most important was narrative. They made sense of what was going on. They went through, they looked at, the people looking at the information, and it was people like the city's epidemiologist, some of our policy analysts. They were synthesizing everything that we had put there, and being quantitatively minded people, we thought, well, why don't you just do it yourself? But, that shows, we're very fortunate to be able to look at a whole lot of data and data visualizations and make sense of it. For most people, they need this narrative, they need the structure to be given to it. And, that actually made us reflect quite a bit about what are the actual uses of things like dashboards and decision support tools. And we think that there's two things. The first use is the use that we all think about and know about, right? And that's about conveying information. It's about, as analogous to the dashboard of a car. How much fuel do I have? What is my power to speed ratio? Is there something desperately wrong with my engine? But there's a second and more implicit use of them. And that's about conveying to people that there's a structure and there's a framework within which they exist. It's to provide calm, it's to provide focus, it's to say, I know that there's a lot going on in the world right now. And mid-2020, it felt like there was a lot. It says, put those things to one side for a second. Just focus on these things. Look at these numbers. Trust that there's a plan. That the world hasn't come to an end. People are still out there building dashboards, so then there's at least someone connected to the internet somewhere. And as a result, that's something that mustn't be underrated and mustn't be undervalued, because as I say, we tend to focus on the first one, that idea of conveying as much quantitative information in appealing formats. But that second use, that emotional use of dashboards, is incredibly important, particularly in large, complicated socio-technical systems, which is what a local government organization is, right? It's a large group of people trying to do a very disparate set of things in a complex setting. And so having a mechanism or a way in which you can present a shared view of things to that audience, and it might get translated and might have a narrative overlay put on top of it, is invaluable. And so that's our final lesson, was that you really need to give people something to trust. Okay, I see that I'm tearing towards my deadline, so I'm going to probably go through this one pretty quickly. But our final lesson is just talking a little bit about what we did and how we stood up those dashboards incredibly quickly. And basically, we had 3 building blocks that we leaned on heavily. Ginger templates, for those who aren't familiar with you, it's a templating library it's a language inside Python. Plotting libraries that produce nice self-contained HTML. And then finally, object storage that can serve as very simple web servers. We use something called Minio, which implements the AWS3 API. But this just gives you an idea of our ridiculously simple architecture, in that you have your end users, they're hitting, we use an Nginx proxy for access logging and stuff like that, and caching. They then are interacting, and they're just simply requesting a very large HTML file that's been assembled via Ginger templates from the object storage from Minio. But it could just as easily be S3 or Azure Blob Storage or Google Block Store, right? And inside those Ginger templates are lots and lots of iframes, the stepchild of the web dev world. In that, as long as your plots expand to fill the size of the container in which you put them, it then completely decouples your dashboard interface from the plots that you're embedding inside it. And to make your dashboard live, you have this final component where you regenerate those static HTMLs and put them into your object store to be incorporated in the dashboard on an ongoing basis. And so you very simply have this dashboard that's live. And this has a couple of advantages, in that it decouples your chart plotting from your dashboard serving. You don't have some sort of persistent server. You don't need to have a Flask service or BI service or Bokeh server or Plotly server running. You just need to have that simple web server serving up content. Most of the heavy lifting is being done in the end user web browsers. It's composable, so it means that different analysts can be working and producing these different plots. And as long as they expand to fill the container that they're given, they don't have to care about the bigger context in which their plots are going, right? I mean, you do for design reasons, but you don't have to, technically, you don't have to worry about them. And this is really, really simple. I don't think it's possible to do it in any simpler fashion. It does have disadvantages, though. It's very difficult to do what they call cross-plot brushing. So if you do something on one plot, you can't communicate that to another plot. The other thing is that you also can't have global plot controls. It's quite difficult to have some setting that you're applying at the dashboard level that then gets applied to all of the plots across them. You can do some tricks where you can have like different sections of the dashboard that you reveal and hide based upon what people select. But it's, it's very clearly a limit. And this is why it's great for like very quick prototypes. We needed something that we could stand up in like a week or two. But the moment you want more interactivity, that's probably when you have to start going to BI tools, right? Just also some final points. I mentioned about the responsive plots that you were needed, and we also found using Bootstrap, it's one of these HTML, CSS frameworks, really great for helping with the layout and managing the layout of those iframes. Okay, so to wrap up, I've covered quite a lot of stuff here, but we've learned these 3 lessons that are mostly about people, in that you need to trust them with information that's relevant to them. When they have that information and you present it in a way that allows them to make choices in their environment. And then finally, you've got to provide people a framework. You've got to provide them with, you've got to acknowledge the fact that when you're building and communicating these products to them, you're helping them make sense of the environment and the setting that they find themselves in. And then I spoke a little bit about some of the technical stuff we've had to learn about building these coherent data sets, addressing that cursor dimensionality, and building super simple, these super simple dashboards that allowed us to do what we needed to do when we did during the pandemic. So just to mention, what we spend most of our time doing, very briefly, we act as a support function to the city. So we work with our colleagues in other departments on projects. We try and work in sort of multifunctional teams with them, following a sort of pseudo-agile process. We employ data analysts as well as data scientists, and then we also have data engineers. And if there's one thing that I've certainly learned over the last few years, it's the disproportionate value of what good data engineering coupled with good analysis can do. So just also to mention, we have some really cool stuff coming down the pipeline. We're building a public data API, which we are hoping to launch early next year, we really want to see what happens when we put data in the hands of the good people of Cape Town, as well as the wider South African community. And I really hope members of this community will consider getting involved there. The other thing is we're thinking quite carefully and trying to roll out data analytics across the city as a whole, and that's very much a work in progress. And the final point, as people always say in these things, we have a couple of posts available. If you have found some of what I've talked about interesting and exciting, please come chat to us. I'm here, and then my colleague Colin, and then Suleiman. Where are you, Suleiman? There's Suleiman, yeah. Please come chat to us, and find out a little bit more. So yeah, I think just to close and to say thank you, to start where I began, which was that dark, cold morning in mid-April 2020. It was a very lonely time, and it was a time when we all felt very disconnected from each other. But because of the work that we were doing, I was using every day the tools that came from this ecosystem, that came from the Python community, and the reason that we're gathered here today. And, for that, I want to say thank you to everyone here for carrying on building that community and that ecosystem. And thanks for listening.
Fantastic. Thank you, Gordon. I should point out I am technically employed as a data engineer, and I feel inadequate now. That was excellent. Thank you. I think we all agreed. Spontaneous round of applause. That was brilliant. We've gone, well, thank you. I wasn't actually asking you to applaud again, but I think that was well justified. The online audience have obviously been so entranced that they haven't asked any questions. They've been paying attention instead. We do have a couple of minutes to take questions from the floor here. If anybody has a question, play microphone jockey.
Hi. Beyond the obvious question, which is why didn't they call it Parks and Recreation?
The department name came first.
Yeah. Some of that you showed, the metrics that you used and the consultative process, seems like it would be a very good idea to package as a service to other municipalities as well. Has there been any thought in that direction?
Yeah, thanks. That's a great question. And actually, also as a fun aside, the people in recreation and parks get really bleak when you call them parks and recreation. But to your question, yeah, I think the difficulty, well, the question would for me is I don't know enough about how other municipalities conceive of the service request type thing. Although, you know, broadly speaking, in terms of performance setting, having a process where you present people with historical information and you actually psychologically anchor them on historical performance, and then you ask them to try and peg their or make suggestions against that. I think that's just a good idea generally. But you know, in terms of building a product around it, it's an interesting idea. I mean, so we have some work that's kicking off too, and we're quite excited about this because it's one of the first tenders at the City of Cape Town that's explicitly open source. So Dimension Data has won that tender now and is starting the work. But one of the requirements is that they're going to be putting code into the public domain, and we're going to operate the system and use it internally, but it's also just going to be in the public domain and available to people. And the purpose of that system is actually a performance management. It's really just a performance management API. It's like an opinionated database with an API attached to it. And maybe that would be the start of something of what you're thinking about, right? Where, you know, you can have a process where people can define indicators, or, you know, you can do things like set targets. You populate that system, and then you build a whole lot of nice visualization tooling that looks at that system and tells you, okay, this is the current state. This is what things would look like. And then people can tweak and adjust the numbers slightly. But yeah, you know, I think it's a nice one. We also, the other way in which we collaborate with other cities is through SALGA, the South African Local Government Association. But to be honest, SALGA, I think, had a rough couple of years and is still coming back. And we've had some recent engagements which have been pretty encouraging. But yeah, you know, I definitely, you know, I think that there's a lot more good work that could be done engaging with other municipalities.
Thanks.
Yeah.
Anyone else?
Either good sign or bad sign.
It's a good sign. It means you said everything.
Yeah.
Okay. No more questions? Anyone good? One final check just on the online side. We've had a couple of people applauding, particularly some guys saying thank you for the positivity. That's a good point. It was a positive outlook to see how these things could work if they're done right.
Yeah, I think maybe just to say too, I think I had it in my notes, but I ran out of time a little bit. You know, I think the only reason we've been able to do the work that we've been able to do is because we have the space and the time and the support within the city to do that work. We're administrative officials, you know, we're bureaucrats, and it's only possible for us to do what we do because we've been given the relevant support. And to be honest, you know, engaging with my colleagues across the country, I know it's very difficult to be positive about government in South Africa right now. A lot more of them would like to be doing that, and I think if we could give them that space and opportunity, I think we might be in a better place.
Now, this is all about like service requests, but like the city of Cape Town is forcing down people's throats, like this policing stuff. You know, well, you know, like the what they call it, like city improvement district policing. And I was just wondering, how does the performance of them get, you know, like how is that, how are their performances being reviewed? You know, is it like with the same metric of like calls and you know, follow-ups, or how is that fitting into this?
Yeah, it's an interesting question. So you know, I must admit I'm not completely au fait on the jurisdictional separations between the different types of law enforcement. So the city operates, there's obviously SAPS, which is run provincially but answers to national government, and then the city operates, we have both law enforcement, and then we also have the city police, and those are both directly run by the you know, they're our colleagues. So they have a system called Epic, which is essentially, it's actually a modified CRM, and a lot of their work is tracked and managed through that, and that data is viewed as particularly sensitive. So to be honest, we haven't actually worked, we've done bits and pieces, but we haven't worked on it in the same systematic way that we've been able to work on the more service delivery focused stuff. But there is a similar, there's no good reason we couldn't extract similar data sets and do similar types of analysis. But the data, the security sensitivities, particularly because they could do quite a lot of operational planning inside that data set. So you can imagine that if people could get access and know in advance what our law enforcement and what our police people were going to be doing, it would could be quite a bad thing, right? So yeah, but I think just also to clarify, the improvement districts are usually run by separate entities that have contracts with the city. So that's yet another jurisdictional separation. And to be honest, I imagine it varies from organization to organization about how they actually are, how they do their performance management and measurement. But I think it's always worth asking these questions, right? Because it's, if you really want to learn about how what an organization cares about, you look at what performance they manage, right, and what they track and measure.
Thank you. I've got one question has come in online. I think we'll take the time for one more question if you can indulge me for a minute or two. We're cutting slightly into tea, but I think this has been interesting and everybody seems interested. Lance has asked, did you find a performance limit with this approach? I imagine he's referring to your static serving through S3, etc. Perhaps in the size of data set or the number of users requesting plots?
Yeah, that's actually a great question. It was actually something we were quite worried about, because we were particularly worried about very spiky workloads, in that our baseline workload will be very limited, but say there's a press conference, or you know, there's a big briefing and someone shares a link and then everyone hits the dashboard simultaneously. What's great about that, you know, using something like Minio, or I imagine, you know, and things like Nginx, or even if you're using something like S3 or blob storage or whatever, is the performance of those things is pretty, the limitation you're going to have is probably going to be your network before it's going to be your software, right, in that instance. And you know, we have so definitely I'm really not I'm not a great web developer, so probably where we had performance issues, it was due to the size of the HTMLs and the plots. And some of the plotting libraries, I'm looking at you, Plotly, ship with like 3 or 4 megabytes worth of JS and CSS. And so we sometimes had to do some things about factoring out the shared dependencies across the plots, but that was pretty easy to do. But yeah, you know, it's, I would say, you know, certainly from the software side, we never had a hint of an issue around performance, but where we did run into performance issues was more about just bloated HTML taking a long time to boot, and you know, that there was a long time to do, and you know, that time to first draw, etc., was a really important one. And a particular offender with that was the maps. You know, those guys, it was very easy for them to get very big, you know, especially when you're drawing those things across the whole city, without you know, the user seeing anything.
Perfect. Thank you, Gordon. I think we'll call it there. Thank you. That was absolutely fantastic. I think we all thoroughly enjoyed that. Thank you very much.
Thank you.